Hello everyone, welcome to this course. Today, here's what we are building. So I have this PDF here, and then I want to be able to ask this PDF with more like ChatGPT. You know, when you have ChatGPT, you can ask ChatGPT any question, right? But in this case, you have your information and you want to create like a chatbot that asks questions based on your PDF. Now we have this sample PDF that I have. That's about DevFest, and I'll build this up, and which is what we are going to be building in this course. And you can ask it questions like, what is DevFest? And it's going to go look through the old PDF and it's going to give you an answer. So the answers are not the same. You can see that it sort of look through and give you context for it. So you can also say, what is GDJ? GDJ, like it's in the PDF, right? And you can see, well, it's not totally correct, but we can ask it any question you want. You can say how to become a member. How to become a member of GDJ. And it's going to look through the whole PDF and give you a context-based result based on it. Yeah. So follow along and let's build an amazing app. So let's get started. I have created a project here. I've called it Ask PDF. Yeah, which is basically what we want to do. And first, we're going to look at all the dependencies we need for this project. And you can see I'm using the SDK here and my Flutter version. Yeah, you can see the Flutter version right here. No need to go into all those details. Okay, but first I need to create a couple of assets here. And I'm going to say assets here, and it's going to point to my assets folder. And then I need assets PDF. So here's where we're going to put a PDF there. For now, we're just going to give it a PDF from the assets, but you can modify the app to upload a PDF and give it some context. Okay. Next is we are going to use a .env file, which will contain environment variables that we're going to put our API keys and the likes in there. Okay. And yeah, because this does not exist, we can create a new folder right at the root of our project, and we can give it assets, give it another folder, and give it PDF. So that should help us with our case here. And good. So we have .env file that we don't have yet, and outside we can do .env here. And we will later put in all the details that we need here. And we save that, all the errors clears up. Okay. So we're going to need for our state management, we're going to be using Riverpod for our state management. So for that, we're going to use Hooks Riverpod, which I like to use because then I'll be able to use Flutter hooks right here, which is good for a couple of things we want to do. And then we are going to put in the build runner, because we are going to be using code generation for our Riverpod notifiers and the likes. Makes things faster. And now that we have that, we're going to use another dependency called flutter.env. It helps us to read configurations from our env file that we have here. Makes things easy. And then I'm going to be using this Flutter PDF package from Syncfusion allows us to more like help us to pass in a PDF and read the text from all the PDF. So when you give it a PDF, we'll look through all the text there, convert it to a text file, and then upload and transform that text to vectors that we put in on our vector database. And then we are going to be using path provider, helps us to gives us good utilities that we use to handle path in our mobile app. Okay, so let me introduce you to some of the things we're going to be using. We are going to be using Langchain. So Langchain is helps us to create this LLMs, large language model, which you can see. So if you want to create contexts aware application, for example, you want to be able to query PDF. The PDF is in this context. It's within that domain context. So if you want to create applications like that, we use Langchain. So Langchain helps us with all the tools. They are for JavaScript, Python. Luckily, we are for Dart, Langchain Dart, I think. Yeah, langchaindart.com. And they have really good documentations here and nice cookbooks. And you can see, helps us with all the tools we need. We are going to be using prompts, embeddings, and a couple of things right out of the box. Okay, so I sort of forked. So let's go to my GitHub here and github.com, and my repository. I sort of forked this Langchain Dart, which I'm gonna be using this tutorial because the original one has a bit of a problem, but well, I think we'll make do with it. But for now, we're going to be using Pinecone, which I talked about. So Pinecone is a vector database. So once you read a PDF text, you're going to be converting it to vectors. And these vectors, you need to store them somewhere. So Pinecone helps us to store all our vectors there. So vectors looks like this. So when you want to query, so you give it a query, it converts it to a vector and sort of compares them and pulls out vectors that looks alike. So this is the vector database that we are going to be using. And then let's give the Pinecone. So the dependency is up here. So if you go to pub.dev, we have it on Pinecone here. So it's a non-official client, but it was great for us. Good. I guess, yeah, good. And then we are going to be using openai, which are the creators of ChatGPT. So you want to go to your personal here. We're going to be using the API keys from there. So you create your own API key, and you need to upgrade your account though to be able to use it. So make sure to upgrade your account. So on that note, we are going to be using the dependency Langchain OpenAI. So I'm going to just put it here and make sure they are installed. And let's see what we are using next. So the Langchain itself, I forked it on. I think I upgraded it a bit. You can see it's using my own GitHub and this ref and the package itself, which we are using Langchain right out of it. And also we are using another package, Langchain Pinecone. At the end of this tutorial, we might remove a couple of ones, but for now, we are going to be fine, I guess. So let's see if they're installed. If not, we're just going to remove the ones that does not work for us. Okay, so let's continue. And while that is installing, we now can, okay, so we have a problem, but we can always fix them later. So for now, I'm going to comment all this out. We probably need to get rid of the Pinecone, but we're good. For now, let's go to the base stuff. In the library, before that, let's put all the OpenAI keys. So the key that you created from OpenAI, let's go to our .env file. We're going to pass it in here. You need an API key from Pinecone, the vector database. So make sure to sign up for an account. That's a free account that you can use. And I think I can log in to mine. And you can see, you can grab your API key right here. And make sure that you take note of this environment, really important. So the next key that we need is the Pinecone environment, because we need to know the Pinecone environment. In my case, it is this GCP starter. So I'm just gonna copy it right here. I'll just paste it here. And for my Pinecone API key, I sort of have it. Paste it here. And my ChatGPT, I'm gonna paste it here. Okay, so good. So you can go ahead and do the same. Now we can look at how our structures are going to be like. So here, I'm going to create a folder called core. In here, I'm going to put a bit of configuration in here. Nothing much, just a config file right here. I'm going to call it config.dart. And it's a service config. So I'm going to give it a name, service config, and say static, create a static string called index name. Let's give it a name. You can give it anything. But for our case, I'm going to give it and say ax PDF. That would be our index name. And then we're going to say a timeout is 8,000, like 8,000 or 80. Because we are going to be using this timeout later. So that's basic stuff. So let's keep it down there. And in the main, let's now start doing some configuration. We're going to turn this to an async. And then we are going to load in, on load, we are going to load in the .env file that we have. We just load it right there. Okay. And then in our main app, we just wrap it with provider scope from Riverpod, because we need Riverpod right there. We can leave the remaining the same, other than you can have a button here, just a theme from the button. So let's sort of give it a theme data and say colors blue. Oh, we are giving it to the wrong one, not the scaffold. We can give it to the material app itself. So just copy that and just give it to the material app itself. Okay. Now our primary squash will be maybe purple. You can give it any color. That's up to you. Okay, good. You can give it some title, but it's an overkill. Okay, so let's create a new folder called view here. This is where our view would go. And we can have home view, like our screen. Home view.dart here. And in the sub folder, we can have notifiers. So this is where our state management files go into. You can make it anything you want. So we create a stateless widget in our home view and call it home view. For now, it's going to return a scaffold, and the body will be just basic stuff. You give it hello world, good. And we'll pass in our home view right to this home folder. So let's replace the scaffold there with our home view. So we just import that to our home view like that. Good, we are progressing. And so now that we've done that, now we can start playing around and creating the services that we'll need. So let's create a new folder and call it services. And here we can create a new service called Langchain service.dart. So this is where we're going to create all the magic that we will need. Langchain service. So let's create an abstract class here. It's not needed because we are doing a bit of a simple app, but we have let's create an abstract class that we can implement later. So here we just create give it a couple of methods, and it's going to be a void. We will need to create a Pinecone index. We need a service to create a Pinecone index. We're going to give it an index name. We're going to give it a vector dimension. And then, so look at it. So we are going to create a Pinecone index. Why do you need to create a Pinecone index? So if you look at my Pinecone here, we have indexes. So this is the index that I have. So it's inside this index that you are going to upload your sort of push your vector after you've converted your PDF text to vector. So you just push it to this index. So anything you want to do, you want to query your index and stuff, you're gonna do it right here. So it's important that you know the index name of what you want to query. You need to know the environment is deployed to, and then the host, and then you see the dimension here that we have. So good. Now we have created an index. Next, we need to create another method to update the index. So after you've created the index, you can update the index with vector or your documents. So we're going to update Pinecone index, and it will take in an index name. But this time it's going to take in a list of documents, and we will call it docs. So when you extract text from extract text from a PDF, you need to convert them to documents. And these documents are what you're going to convert to vectors that you upload. So this document is from Langchain. It's not from HTML. Now let's go back to our dependencies now. Now we really need this Langchain. So for now, I'm going to comment out this openai. So let's bring back Control K. How does it work? I think it's Control K, Control U. Yes. Now let's bring back this one. Let's install that. A Langchain.dart from package Langchain, because it's inside this Langchain that has the documents that we need, so that we be able to import it here. See? Import library Langchain. Good. So this one is just taking time, but we are able to do that. Okay, so the last method we will do is, so after we've created a Pinecone index, we update Pinecone index. Now we want to query, so you can ask it some questions and it will return some values to you. So in our case, we want it to return a string. So when we give it some query, we want it to query Pinecone index. So we want it to query Pinecone index, or we want to query the vector itself. We want to query the vector store, but we're going to still give it an index name and then a query. So we want to query the vector in this index. Good. Now we can create the implementation of this Langchain here. So in the services, I create a new file called Langchain services implementation. Just do impl.dart like this. So we say class Langchain. I don't like that it's Langchain services, so I'm just going to change it to Langchain service. Makes sense that way, not services. So Langchain service implementation is going to implement our Langchain service. Pretty slow typing here because it's organic. So let's see what we call this. Oh, we call it language service. So let's change it to language service itself and then just put it here. And we can import that from the Langchain service. So you have this red squiggle here, and we can just create our 3 missing overrides. That means we need to implement this service now. Yeah, so let's go ahead and start implementing each one of them. Okay, so what do we need if we want to, use this service? We want to create a service. We are going to be needing final Pinecone clients. And I'm going to call it client here. We need Pinecone itself. We'll probably remove a couple of ones here because we might not need them. But for now, just bear with me. And then we will need OpenAI embeddings. So when you want to query, you need to, or you are creating the vectors, you need to create an embedding that you embed in it. So we have OpenAI embeddings. And we call it embeddings. And then we need to inject OpenAI 2. So we have OpenAI right here. Okay, good. So which one can we import? We can import none of them. That's interesting because... So let's go ahead and see our dependencies, which one we can fix there. So we need Langchain Pinecone. Let's save. I hope it doesn't. So Langchain Pinecone from Git depends on Langchain hosted. Let's see. We need to solve. Okay, that's not the one. Oh, okay. So I think a way to solve this is to create an override. We can create a dependency override here. So let's just keep our OpenAI here. So now you can see the problem is that they all depend on hosted and one depends on Git. So if you go down a bit, you can create a dependency override to override the dependency. So you can do dependency, where is it? Dependency underscores overrides. Yeah. And then we just override it with the Langchain from my Git repository, like this. So I think it works. So we need to push this a bit. Okay. Let's see. Okay, this has to go out. This has to go back a bit. Yeah, this sort of work. But it makes sense to just put it back a bit. And yeah, we are good to go. So let's see. Does it install? Good. We are good to go. Okay, so let's go back to our Langchain service and we are able to import Pinecone. Able to import. Good. So if I click on this light bulb here, we will create constructors. We'll be able to create constructors for the automatically. So we just make them required. So just create final fit here. So it automatically creates them for us here. So let's put a comma here. Good. Now we have all the services we need injected right here. If you want to put it back in, the documents here, just import. So if you want to put it back in, we just need to inject it through the provider. So it will work for us. So let's just create. So let's now start implementing some of this. And in the create Pinecone index, let's print. First, we will check if the index exists, because you don't want to create it once it already exists. So now we are going to check. So existing index, or just say indexes. I don't know if it's correct, but this is going to be a feature, so we need to put an async here. So we say await client.list indexes. So we want to list all the indexes that we have right on Pinecone here, so that if it already exists, there's no need to create it again. But if it does not exist, if the indexes does not contain index name, let's create the index. So creating index name that we passed in here. And then we can start creating. So we are going to use the client here. It's from Pinecone client. We are going to do create index. So it needs a request. So a request is a create index request. So we just pass it right there. So create index request needs in an index name. It needs a name. So name. It needs a dimension. So we give it a dimension. Now the metric, we are going to use search metrics.cosine. So it's going to use the cosine to do the vector similarity matrix. So let's give it a cosine. Okay, so we are able to create the index. Also, we can make sure to give it an environment because by default it uses the US whatever. So environment. Now, if you want, we need to remember that in our env file we have Pinecone environment right here, GCP starter. So you can just do .env.environment.pinecone, and then we look for the Pinecone environment there. If not, it uses the other one. Okay. So let's continue. And yeah, we are able to create Pinecone index. And I want to do something here. Let's sort of do a try catch. Should I do a try catch? Or there's no need to just do else. So that it just shows us that the index name already exists. Okay. Also, I want to add a last print to it, which will be this one. So we want to show it on our terminal that we are creating the index and that we should wait for it to finish initializing. So, because it can take a while to create the index. So if you like, you can put a delay here, maybe like 5 seconds to delay it a bit. You can do something like this. But for now, I'm just gonna take it out. Now let's do updates. So after you've created, you want to update it. So we need to first retrieve our Pinecone index. So we're gonna retrieve it first. And then how do we retrieve? You use, let's get the index. We can use client dot. So there's a describe index. It gives you the details about an index. So we give it an index name, I think. It requires an index. So we give it an index name. Oh, it should be capital letter name here. So the same thing we do for the environment. You can put it in a variable but for the purpose of this tutorial, you just give it. So we want to get the index name from this environment. And then we will just print, and let me get this out of the way so you can see. So an index is a feature. So let's make this async, and then we do an await, and you can see, oh, we have delete instead of describe. So it's a describe index. So you can see that we have index of type index here. So, and we can do index.name. Okay, so now that we've gotten the index, now let's start playing around with the docs. So what do we want to do with the docs? So we want to get all the documents in our list of docs. So final doc in docs. So let's print. So we are processing this doc. So for every doc, it has something called the metadata. So how do we? Let me show you from the documentation. So let's go to document here. So interface for interacting with a doc. You can see a doc has a metadata, which is a map. So the page content is the text content of the document, and the metadata is also a map here. So the metadata contains more information about the text that you're working with. So I hope that is clear enough. So here we just want to check the source. So it might not print anything, but it's good. Now we can put the text inside the doc.page contents. Remember I told you that's where the text of the doc itself is. Now we are going to split the text. So let's split all the text in each of the docs. So we're going to have a const text splitter. I'll call it a text splitter. And there is a method. There's a class in Langchain that allows us to split. That allows us to split text into like chunks. So we give it a chunk size of 1,000. There you go. So we've created it. Let's make it a final. Oh, it wants it to be a const. Okay. So we created a text splitter that is a recursive character text splitter here. So it takes in, it splits a text that looks at characters. Recursively tries to split by different characters to find the one that works. Okay, so now we are going to create documents from this. So, and we create it chunks of data from it. So we will say text splitter dot create document, and so our text, we put it in a list like this. So the text from a doc, we just create document out of it using our text splitter. So the create documents create a document from a list of text. So let's print, and we'll print it here. Let's print and know how many chunks that's created from this chunk. Now the next thing is we are going to call OpenAI's embedding. document. So we are going to embed all these chunks that we've created. We are going to embed it into OpenAI. So OpenAI embedding endpoint documents. So we are going to put in all those text chunks right inside it. Let me just close this. So let's create a map of chunks now. And we say final we do first? We need to upload the PDF to be able to ask for context, right? So in this case, I'm going to use an outline button. I'm going to give it an unpressed, and the child is going to be, I'm just going to tell it to upload PDF. Simple. Okay, because that's what we are going to do first. Okay, good. So let's create the logic for our index. So let's say we want to do for upload PDF now. So let's just go in our notifier. I'm just going to say index notifier dot. And here I'm going to say class index notifier is going to extend, since I'm using code generation, so it's going to be index notifier. Let's delete this one. And here I need to annotate it with @riverpod from riverpod annotation. And I need to create some index states to tell me the states of our index. And then I'm going to have a path file here where the code gen is going to go into. So let's go to our terminal and let's run our build runner. So you do that run build runner build, and it will create a generated file right here. It failed. Why? We must define the build method. Okay, good. So we need to override, and we do the index state. Our build will return an index state. So by default, the state is initial. So we can run the build runner again and we'll be fine. Okay, so it's created the file for us. So now we can go ahead and start create and upload Pinecone index. It will be an async. So const vector dimensions equals to 1536. Now the state will be index state.loading at first. Then we can do some try catch here. Now we need to call our service that we created then. So let's go back to the line service thing, and then we want to be able to provide the service to our notifier. How do we do that? We create a provider and we say Langchain service provider equals to, let's create a provider. It will return a Langchain service. And it will take in a ref. And then we open it up. Okay, so we will then import it from Hooks Riverpod. We need to return something here. So first, I'm going to say Pinecone API key. We need to get that from our .environment. So we put it here. And then our environment itself, we need to get it right there. And then our openai key. Now we need to create our client, a Pinecone client. You remember that we need to pass it in here. So our Pinecone client will have this base URL, controller.environment, this environment that we have, .pinecone.io, and then our Pinecone API key. Our embeddings will be OpenAI embeddings. We just pass in our OpenAI key, and then the Langchain Pinecone that we use. So remember that we had our index name in our service config. So we need that, you see, we need the API key, index name, embeddings, environment, and then the OpenAI right here. We need it as well. So we basically just return. So what we need to do is to return a language service implementations, and we pass it right here, and we inject it right there. So anytime we need to use any of the method, we just do call the provider here. So in our case, we will go back to our index notifier and then just do await ref.read Langchain service provider, and we import that, and then we do create Pinecone index. So our index name is for our service config dot index name. Okay. Now let's fetch some documents. So let's say docs equals to await fetch documents. So we need to create this fetch document method. And what does the fetch document method do? It fetches documents from our PDF. So to be a feature lists of documents. So the documents are from Langchain, remember? So we just put fetch documents there. Now it's going to be a sync, and then we put a try catch there. So now we need a text file. So we'll create a text file from PDF. Unfortunately, we can't directly upload a PDF to upload the, we don't have the utility to upload directly a PDF. So the hack around is that we are going to create a PDF, because we have only a text loader in Dart. We have text loader, we have CS feed loader, we have web loader as part of the Langchain methods that we have. Unfortunately, we don't have PDF loader like other languages like Python or those ones, or JavaScript has. But what we can do, since we have text loader, we will get a PDF, convert it to text, and just pass it to our text loader. So in that case, we need to create a method which is going to return a directory for us where we will save the text. So let's just do try catch here. So we'll load the PDF. We load the PDF right here. So how do we load the PDF? We will use root bundle to load the PDF. So root bundle.load. So that will mean that we need to put in a PDF right there. So let's look for a good PDF to use. How about the PDF that the dev first PDF? So I'm going to drag it right here and just rename it to sample.pdf. Okay, good. So we can load from sample.pdf now. And then we can, now that we have the PDF from assets, we can use PDF document from the Syncfusion PDF that we added here. And where's it? Syncfusion PDF. So I don't know why it's not. Okay, yeah, good. We have it here. And then we'll now extract the text from it. So how do we extract the text? We will just do PDF extractor still from Syncfusion. And then we call the extract text. So it's going to extract all the text for us. Now, so after we extracted the text, we need to save the text somewhere. So in our case, we are going to just save it to a local path, which will be in our assets. So let's create a simple method that is going to return our local path for us. So I did from path provider, we can get a string. From directory, I will get application document directory and return document. So it just we just get the application directory and it's going to, that's the local path. So then we create a file with our text. So our file is from .io. So you see, I pass in the local path and the output.txt. So that will be the content of our PDF. And then we then get the text from the path and we write it as a file. So we dispose the documents. We document.dispose, and then we return the file path right here. And if we don't, we're just gonna throw an error here. So now you can see that we have the text file from PDF. So once we have the text file from PDF, we just call our loader from Langchain. So you see loader takes in a file path. So the file path of that text file, we just pass into our loader. And then it creates documents from the loader. You see, this is a list of documents, Langchain documents. Await loader.load. It returns a document. It returns documents from us, for us. Else we just throw a nice little error here. Good. So now from the await fetch documents, now that we have the docs, we can then do await ref.read updates, not upload. So we are going to do update Pinecone index with the documents. If not, just set the state to error. If successful, we just put it to loaded. Now we are good to go on that front. So now we can hook that to our front. It's pretty easy. So we're just going to go to our home view, the upload PDF right here. We just do ref.read create Pinecone index. So index notifier provider, we import it, and the index notifier provider is from our index notifier here. So it just adds provider to the front of the name. From our generated file, you can see index notifier provider. So now we have created a simple solution. Now we can test if it has uploaded. When we click on upload PDF, let's test if it uploads. We have this my test tutorial index before. So let's see. So we upload PDF. Where's our output? I'm supposed to see it. So let's reload. Let's upload again. Oh no, I can't see any of my debug. Let's see. Let's refresh. Not here. Let's see if it's clicking. Oh no, it's not. Oh, I put it in the ask instead of I put it in the ask instead of the upload PDF. Okay, good. So let's test it again. Upload PDF. Good. You hit this breakpoint. Let me remove the breakpoint. See, checking ask PDF. So OpenAI is saying API key is set, but it's not valid. Okay, so let's check our API key again. Let me go. Oh, okay. I see why. So let's refresh and upload PDF. API key set to blah, blah, blah. Good. Creating ask PDF. Let's see language service. Is it hitting any of this? Creating as PDF. Okay. So we are going to wait for it to finish initializing. I guess it takes a while. Yeah, it can take a while to create. It takes a bit of time. Okay. I think I tried it a couple of times before. So while that is doing, let's write a notifier for our query. So when you query it, you want to see the results here at some point. So let's create a query notifier dot. So we're going to have a query enum, initial loading loaded error, and then we are going to have our query state. So our query state, we take in the result and the states. And then we can create a notifier. So it's going to be query notifier. It's going to extend our query notifier here. And we can import from Riverpod. And then we are going to override the build like this. And let's run our build runner so that it creates that for us. Oh, we don't have a path file at the top, so it's gonna be a bit of a problem, but we have it now. Can you please create it for us? See, it's already complained. But anyways, we're going to create a void method that is going to query Pinecone index, like our vector. And then it will be an async function. And the initial state, the result is going to be empty. And then we have a try catch. So in the try, we're just going to read our Langchain service. So we use the service provider to do that. We get our index name for our service. And then the query from the string here, we just put it. So, and then the state will now be the query state with our result, which is a string. So it's going to show enum loaded. Else, it does not. There's a problem. We just show an error. So that's about that. And then we go back to the UI and we just basically just tell it to query. So in this axe here, we just do ref.read query notifier provider here. Yeah. And you can add a form state here so that if there's nothing in the form, it doesn't do anything. So at the top here, I'm going to add a form key so we can wrap the whole of our column in the form and then pass in the key, which is the form key here. And we can watch our query notifier at the top so that we can get the states of our query notifier. And so that when we have some data, we can always show it. So down here, after this upload, we have a size box, and then we have if query state the state is loading, just show a linear progress indicator. If it's loaded, then show the result down here. Simple logic. So now I think we are done. Now we just need to check if what we have done is good. So let's go back to our Pinecone index. So apparently it has not uploaded. So we need to figure out why. So at various points, I'm going to let's see if it works. If I put in a breakpoint here and there, and then let's see, upload PDF, I'll wait, create index. So does this say index already exists? No. So there's something wrong here. And I'm not seeing anything. Okay, so I think what we need to do is to run the app again. Let's see. It's because it initializes the packages again. So let's see. So I'm getting wrong. Okay, update the pods. Okay, it's done. It's gonna launch soon. Okay, so it launches, and let's try again. Check an index. Okay, so I think we can put a try catch here to see what the problem is. I think it just continues anyways. So let me. Oh, this is the query. So the query doesn't matter, but it never got here. So let's see. Creating. It does create. If indexes that contains does not. Just checking. Does not contain. Okay, I need to see the list of indexes. I see. So indexes is 1. So our index name is ask.pdf. Okay, I think I may know why, but to really see, I need to put this in a try catch. Okay, so I put all this in a try catch, and then we print the the error. So let's just put a breakpoint there. Okay, so the error is right here. And it's saying index name must consist of lower case alphanumeric characters or dash. See why you need to use a. Now it's printing. You see why you need to use a try catch. It's really good. So we need to go back to our config here and just give it ask-pdf. Let's give it some index. Okay, good. So we can try again now. Upload PDF. Oh, say startup projects only consists of single index. Oh, so I'm using a startup project. So let's see if I can delete this off. Delete index. Terminating. It takes a while to terminate, but we can try again. It is still. Okay, so it has deleted. So yeah, good. Let's see, creating PDF index, processing document. These are outputs.txt that we have. See the path. We didn't bother about the path here. And then split the text into chunks, calls openai embeddings, put it in the embeddings, finishes it. Then it creates the vectors with ID values and metadata, which is this update, which is down here. This is when it's calling OpenAI's embedding and then creating this. So now it's doing this one, which is updating it. So that's the last part. So it takes a while, I guess, to finish up. So, but we can see it here. So it takes a while for the thing to do. I don't know how much time it takes, but we'll see. So we are awaiting this actually. So it's actually here. And with that, once it's done, then we can be able to query the document actually. But with this, it's going to work. Once it's uploaded, we are going to be fine. We're already here. So just add all these vectors to where we have it. So it looks like, oh no. Okay, go. How do I know it's going to be successful? I can try again. So we waited a bit for it to upload. Apparently it didn't. So let's see what the problem is right now. To get an idea of what the problem is, let's try put this in a try catch. So we can catch the error and actually see it on the console. So I'm going to copy all of this. Oh no. Let's copy can be a bit of a. Okay, so we paste it in the try. And then here we just print the exception right here. Good. And then let's try to upload a PDF. And you can see that it's showing index not found. And the reason is the URL is wrong. If you actually want to upload, you have to use this host here if you want to add your vector. So apparently this Langchain Pinecone thing does not work. So we can't do add vectors. So what we can do is we're going to use the upsert method. Let's see. I think it's right in the documentation somewhere. So let's do Langchain dart. And let's look for upsert. Oh, it's not there. I think it's on Pinecone itself. Okay, Pinecone, not Langchain. So if we have a couple of method updates, delete, query, upsert. So now we're just gonna take all our vectors that we have and then upsert them. But right now, the embeddings we have is a list of double. Instead, let's use the upsert method from our Pinecone client. So that means that we need to create batches of the arrays that we have. So first, let's create a variable called batch size and then give it 100. Okay. So we are going to write a for loop. I'm going to say int I to 0 and I is less than chunks dot length and I plus plus. And then we look through a chunk So we say final chunk. Yeah, is the index of chunk. And then we do our embedding array and use the index on our to check our embedding array. So let's create our vector now. So we can create vector and say, give it a name and say chunk vectors, and we set it to a list. Now we can create a chunk vector, and it will be vector. So now let's compose vector. Vector, what will be our ID? Let's make our ID the text path. So to get the text path, let's go up here and say, and use the source from the metadata. You see, we are getting the source, and let's just use the, let's just use the metadata as the source path. So we go back down there, and we just, normally you can just give it the I, that's the index, but you can just do text path, and you can give it an I. So let's, like this. The values will be the embedding array here, and then each vector has a metadata. So let's look for the metadata. Metadata will be a map. So we add the chunk.metadata. We can add in a couple of other values that we want. You can say JSON encode, and then chunk.metadata, the location. Sometimes it comes back as null. It's not really important, but you can. Now for our page content, we use the chunk.page content, and then the text part, we use the text part here as metadata. So it just gives us more information about the chunk. And here we can add a chunk to the chunk vectors that we have here. Now we can say if chunk vectors.length is equals to our batch size when it gets to our batch size, or our I equals to chunk length, chunks.length -1, and we can then just upsert. You can then upsert, but this time instead of just using clients, so normally we do client.upsert vectors and our vector here. So let's look for the required. The project will be index.project_id because we got the index from top there. The environment, we have it. For the environment, you can just use the environment on the index anyway. So we can do index.environment. In fact, we can do index.indexName.name. Yeah, for the vectors, there's no vector, but we can do it in this request. So request does take in an upsert request. So we compose that upsert object, and it takes in a vector, and the vector will be our chunk vectors right here. And then once it's done, we just set our chunks vectors to empty. Chunk vectors to empty. Pinecone index updated with chunks.length vectors. Good. So let's try to upload. So we're uploading. Oops, we have another problem. See, HTTP controller GCP upsert. So unfortunately, this URL is wrong and it's from this client. It's from this client up there. So what we can do is to create a new instance of client here and give it the correct base URL. And if you see Pinecone documentation, you look at docs and we go to upsert. So the post request is a post request, and you can see that the base URL is the index name, project ID, svc environment pinecone.io. Unfortunately, that's not how this is formatted, the URL here. So what you can do is to take in a Pinecone client here, and we have to do an API key. We get the API key from .env, and then the base URL, we are going to compose it here ourselves. So this time is going to look like this. It's going to look like this one, the base URL here. Let me show you. So how do you increase the text on the screen? I think, yeah. So the base URL is right. Okay, it's more clearer here. You can see the URL. So we literally just do this. So we pass in the index.name, the project ID, svc, the environment. So you can see project name, index name, project ID, svc, environment to form our URL. And when we save that, we can then try to upload again. See, Pinecone index updated with one vector, and it is done. You can see we have a list of our vectors right here. See our vectors right here. You can see if you overrun it, you can see it's what is dev text. You can see the text part, location as well now, but our page content contains all the text from our PDF, which is good, which is what we want. Now we can ask it some question and say, what is the first? And we ask, request finished successfully. Let's give it a question mark. Okay, so we don't, it's always coming back as null. So let's look at what's going on. So let's go to here. I want to use our try catch as well here in the query method, so that if there's any problem, we can always catch it. So we print our exception, we save that. So let's just throw an exception, error query, because it needs a return value. Okay, so ask. Okay, so we have our exception here. So what's the problem? Index not found. So you see the problem there. And it is back to our client that we have here to query our index. So let's return back this base URL that we have at the top of our Pinecone client. Because if you see, you can see, I think so. So let's ask again. Oh, index not found. It does not found our index. Let's query. So let's put a breakpoint here. It's not reaching there. Okay. We get the embeddings, similarity search by vector. So I think this is the one that is giving us an error. Now, if you've noticed, we are not using an index anywhere. So inside here, so I guess we need to go back to using the client anyways, because now we can get the embeddings anywhere. So what we're going to do is, let's get rid of these, and then we can use the client that I think it has a query method. So we can query vectors. Yeah, I think that's better way to put it. And so let's see what it gives us. So we can now use index.name, index.project ID, index.environment, and then the request is a query request. So let's give it a query request here. And what does it need? It needs a top K. So let's say top K, let's set it to 10. And what does it need again? What else? It needs a vector, the vector itself. So let's give it a vector, which will be the query embedding itself. So the result will be result.matches. So if there's some matches, and then we have matches here. And we can give it some nullable here because metadata is not going to be null. Or we can add a check here. You say if e.metadata is equals to null, then we return an empty string. So let's put a breakpoint here. Yeah, I think, and we can test it out. So let's refresh. And then, okay, so you look at the, let's just, what is def first? Let's ask. So now we get an unsuccessful response. You see, we have a 404. So that brings us back to the thing we did the other time. We just initialize the Pinecone clients directly and then pass in the Pinecone client. I guess you could do it from inject it, but I just want you to get the concept of what you are trying to do. So when you get it to work, you can refactor to your benefits. So now when we just query the vectors here, just pass in the Pinecone client with the API key and base URL, and we can ask. Oh, it gives us some response. You can see the question, what is def first? But there is no metadata, so I'm not sure what it, okay, it's returning some output for us. Let's put some breakpoint there. It returns some output, good. But we don't have some metadata because it never hits here. And I think it's because in this query request, we can tell it to include metadata and give it a true, include values and give it trues as well. So now our metadata is going to see we have metadata now and some page contents. Good. So our app is quite running. It's running quite well. And you can ask it multiple times. It's to give you the right. What is GDG? I can ask it. Google Developers Group. So now this is how to create a semantic search application in Flutter. You give it your so in your case, you could do it that you can take in some PDF and put it here. Remember that the index name now has to be dynamic. We are only using one index because we are using only one PDF. So we are going to be having several PDFs. You want the index name to be unique to that PDF, right? And you can decide to put in some authentication around your app and then make it a solid app itself. So anybody can put in their PDF, ask some questions, and you're good to go. So I hope you enjoyed this course. I'll be doing a couple of more stuff as I just discover things. I'm going to leave the code in the description, and so you can look through the code and edit to your own taste. You can refactor a bit. Like for example, we are no longer using this Langchain Pinecone since it's giving us issues, so I remove it and refactor this to outside to inject, and we have a good solid app in your hands. Thank you for watching, and my upcoming course, a Flutter developer full course, is coming out soon. So like and subscribe to this channel. See you in the next one. Bye.